so much for your words, both you and Sonia and Jason. I think a good sign of a very intense program is that you're late from the very beginning, which is very exciting for us. So I'll keep the introduction very short and let Isha speak. So we're very excited to have Isha here. She's been a pioneer in the field of cellular agriculture, which I must admit I had to look up after interacting with her just to know more about this, and it's very exciting. So probably she will tell us more in her presentation. It's very exciting to have her here, and I'll keep it very short by just saying that she has Isha has a BC in cellular molecular biology from the University of Alberta, and a master's in biotechnology from the University of Toronto. And Isha is currently a Shuttleworth Foundation Fellow. So it's very exciting for us to have her here, not just because of what she does, but also because she's part of this institute that actually funds research into cellular agriculture, which is a very interesting model that we hope that we can also explore here in LA. So thanks, Isha, for coming, and I believe that your presentation is...
Thanks so much, Yari, for that introduction, and thanks so much, Jason, for that little preview into what I do. I didn't actually know you could swear in headlines, so that was interesting to see. So when Yari invited me to speak, he asked me to talk a little bit about what I do, but also about how I'm doing it and the entrepreneurial experience around it. So the talk that I'm giving is a little bit different from what I usually give. I'm going to try and weave together the work that I do today with some of my personal experiences and how I got here, and I hope it will be useful and interesting to everybody here. Yari, I hope you can help me stay on time. I'm trying to do things a little bit closer so that we have some Q&A afterwards. Okay, so I called my talk The Unconventional Entrepreneur because usually my talk is something called, like, what is cellular agriculture and so on. But as you know, I'm giving this kind of unusual talk about entrepreneurship. And I actually was lucky that I didn't have to come up with the name of the talk myself, because just a few days ago, my university put out their university philanthropy magazine, and surprisingly had me on the cover feeding a horse, even though I'm very allergic to horses. And they called it the Unconventional Entrepreneur. And I think that as I go through my story, you'll realize a couple of things about why it's so unconventional. Yari already mentioned, but I did my undergraduate degree at the University of Alberta in Canada. If you've never been to Alberta, it's kind of like the Texas of Canada. So it's all about oil and gas and the cattle industry. And then I went and did my master's degree at the University of Toronto. It's a really interesting program called the Masters of Biotechnology, which is kind of like an MBA, but just focused on the science industry. So there's a lot of interaction with pharma companies and other actually not so much ag, but other biotech companies all the way through the program. It's kind of a novel thing in case you want to check it out. So I like to begin my presentation by talking about how much I love animal products. There's things that animal products can do that plant proteins just can't do. So for example, an egg can whip up into a fluffy meringue. It can elevate a cake. It can make these incredibly creamy sauces and custards and so on. There are no plant proteins that can do that. There are proteins that can do maybe one of those things, but not all of them. There are also very few proteins that can make a really good cheese. Casein and whey and milk proteins can create these really stretchy cheeses. They can fry up to make these little crispy parts of pizzas and things like that. And plant proteins just can't do that. I don't know how many of you have tried a vegan cheese, but you'll know there are a lot of compromises when it comes to products like that. And lastly, meat and muscle proteins. There are few proteins that can hold together fat and water, as well as the muscle proteins in a hot dog, for example. So there are just all these incredible things that animal proteins can do. But there's a lot of problems with animal products as well. The first is that they ruin the environment. And I have a lot of statistics about how they ruin the environment, but I'll keep it really short. The thing that stood out to me is that we use 70% of agricultural land on Earth to raise animals. And when you consider that usually animal products are not the biggest part of your plate, that's kind of surprising. I also like showing this image because it's just an aerial photo from Google Maps of a feedlot in Texas. And you can see that each of those tiny little sunflower seeds are cows, and they produce so much runoff that it entirely damages waterways. So the Gulf of Mexico, for example, all the way down the Mississippi River is pretty much a dead zone because of all this runoff leading to algal blooms. So animal products are quite detrimental for the environment. They're also incredibly unsafe from a public health perspective. So antibiotic resistance is largely driven by animal agriculture, and we also see so much food contamination come from animal agriculture. When you hear about E. coli in spinach, it's not because of spinach, it's because the spinach has manure from farms upstream or things like that, or various animal products coming in touch with them. Oh, and I didn't even mention the viral epidemics, which is what is pictured here. So as we have animals so closely packed together, we create just an incredible environment for viruses to jump from animal to animal and mature and jump from animal to human. So we're seeing these outbreaks happen ever more frequently. So I think there's a lot of things that we need to do on the public health side when it comes to preventing these issues coming from animal agriculture. And the last problem, I think, with animal agriculture is that they come from animals. And I show this picture of a pig farm, and a lot of farmers tell me this is actually a pretty good pig farm. But I think just by looking at it, we can realize that there's a lot of improvement that there could be when it comes to raising animals and animal products. And while we are familiar with a certain type of packaging and imagery when it comes to animal farming, the vast majority of animal products we eat don't exactly look like that. Lastly, I think it's important to point out the climate change aspect of animal agriculture. So animal agriculture every single year releases 7.1 gigatons of carbon dioxide equivalents. And it's kind of hard to visualize what that means. So I pulled up all of the carbon emissions that come from all fuel burning in the top 5 fuel burning countries. And you can see that for the very same year, this data is from 2005, animal agriculture produced more carbon emissions than all fuel burning, all combustion in China. So it is an incredibly huge source of climate change. In addition to the effect that animal agriculture has on climate change, there's also the effect that climate change has on animal agriculture. So as we see a change in climate, we notice that animals are just not producing as well. They're using so much more of their energy to maintain their own temperature than they are to producing meat, milk, and eggs, for example. So productivity goes down, fertility goes down for the same reasons, and health decreases. And some of that is because of climate, and some of it is because of all the downstream effects of climate. So as we see, our summers get longer, for example, we see many more pests and diseases sticking around for longer. And so that's another thing that affects productivity, fertility, and health. And those are kind of just the general changes in climate, but there's also extreme weather events that are happening with ever more frequency. And I just pulled up 2 headlines from the past couple years where a rogue snowstorm in South Dakota killed 100,000 head of cattle in just a couple days. And then a similar thing happened in winter of 2015 when a storm in Texas killed 40,000 cattle. So not only are we seeing these events being terrible for farmers and terrible for food security, we also have to realize it's very bad for business. So all those images that I showed you earlier, I like to say that animal agriculture, we're reaching planetary limits with what we can do with animal ag, and that 70% of agricultural land is one fact that really illustrates that for me. But in addition to the planetary limits that we're reaching with animal agriculture, I also think we're reaching biological limits with what we can do with whole animals. So this is some research that was done at the University of Alberta, where I went to school. I didn't do this research. But at the University of Alberta, they keep many heritage breed chickens from decades past. And so these are chickens that are approximately the same age, and they are breeds from different years. And so you can see the breed of chicken from 1957 looks a lot like a bird does, like a pigeon or a crow or whatever. And just by choosing which 2 chickens to breed with one another, we've created the chicken of 2005, which I think is very safe to say is a chicken breast growing machine. And so we've really reached biological limits when it comes to what we can do with chickens, to the point that this 2005 chicken has to be slaughtered, otherwise it will be literally too big for its own legs. So I pulled this quote from the National Climate Assessment, which kind of factors in all these things about how climate change is affecting agriculture. And I thought this quote was really important. It says, based on projected climate change impacts, agricultural systems may have to undergo more transformative changes to remain productive and profitable in the long term. And when I think about this chicken, it's hard for me to think that that transformative change will occur in our existing models of agriculture, which are based on whole plants or animals. So that's where I like to propose my work. I think that the transformative change that we need in agriculture is cellular agriculture, which is the idea that instead of relying on whole plants and animals for agricultural products, we can derive those same products, but from the basic units of life, which are cells. So there's the definition that we came up here. Here's a quick side interesting fact is that back when I started this research well, I guess it's not research, but back when I devoted myself full-time to creating these products in 2014, there came a point where I was like, we need to actually come up with a name for what cell-cultured milk, cell-cultured egg, cell-cultured meat would be. So I actually went to our Facebook group and I said, what should the name of this field be? And we had a huge thread of people throwing out all kinds of really interesting ideas, and cellular agriculture was the name that stuck. So it was kind of a cool crowdsourced, community-driven thing that arrived at the name of this new field. So cellular agriculture, we include any kind of agricultural product derived from cell cultures. And those cell cultures could be animal cell cultures, they could be algae, they could be microbial cells, plant, yeast and bacteria. And the products that we can get from these cell cultures can be all kinds of things. Right now, we actually already get many flavors, fragrances, enzymes, and food ingredients from cell cultures. But what's a little bit novel and different, and I think pushing the cutting edge on this, is materials and food and kind of larger scale commodity products that are made with cell cultures. So for simplicity's sake, I like dividing cellular agriculture into two main categories. There are products made by cells and products made of cells. So the products made by cells are the ones we're more familiar with. And I drew an example here. So milk, for example, is merely a collection of proteins and fats mixed with water, more or less. And so we can derive that protein, for example, casein, from a yeast culture that has been genetically modified to produce casein rather than from lactating cows. And what we have in the end is the same protein. We just reformulate it with the other proteins and fats and should be able to create milk in the end. And I realize that is a huge oversimplification of what the process actually looks like, but what I'm saying is that you can produce those identical proteins without having to rely on a cow for it. These are some of the products that we already derive from cell cultures. This is by no means comprehensive, but I like pointing it out just to show how familiar we are with cell culture products being something that we consume. Rennet, for example, is the enzyme that is used for cheese making, and for years and years it was created by getting the fourth stomach, I think, from a calf, and you're not really supposed to wash it, so it's kind of could be contaminated because you need to keep the rennet enzymes stuck to the inside lining of that stomach, and so you would mix that with milk and whatever to make cheese. And you can understand why that's slightly problematic, but around it actually was March 1990, I remember because it was my brother's birthday, the exact day, when the FDA approved rennet that was made entirely through a biotech process where I'm not sure exactly what organism they use, but the chymosin enzyme that transforms milk into cheese was created using a genetically modified organism. And so now 90+% of cheese around the world is made by this very controlled rennet, which behaves the same way every time, and you don't need to rely on, I guess, a stable supply of calf stomachs in order to do it. And then, of course, there's vitamin B12. A lot of people consume animal products because of vitamin B12, but what we don't realize is that vitamin B12 is actually created by microorganisms in the gut of animals, not in animals itself. So by just cell culturing those microorganisms, you can generate these vitamins. And monosodium glutamate, MSG, is another cell culture-derived product. So the milk project that I mentioned earlier was actually the very first project that my organization, New Harvest, kicked off. It was founded by 2 people within New Harvest community and myself, and it was initially called the New Harvest Dairy Project, and then a company called Moofree, and is now called Perfect Day, and I encourage you to check them out if you're curious about animal-free milks that aren't plant-based. Their story is very much intertwined with mine. I founded the company with them, but when it came time for them to get their very first kind of pre-seed funding, which was $2 million, it was a really funny story where I don't know if I'm going to go into that story. Maybe I'll get into it later. But anyway, when it came to them raising their first funds, I remember being in the office with the funders, just about ready to sign the term sheet, and said, you know what, I'm probably going to be creating competitors to this company. Is that going to be allowed if I'm a founder? And they're like, no way. So I actually gave my personal equity in Perfect Day to New Harvest. So in the event that one of these very first cellular agriculture companies succeeds, we have an endowment to fund early stage research through the charity that I run now. Interesting model. So several months later, the same thing happened with a company called Clara Foods, where we realized, oh, if we can produce milk proteins this way, why can't we produce egg proteins a similar way? So Clara Foods is a company that also came from 2 New Harvest members, and when they came to raise their funds, I also gave up my equity to New Harvest. So in the event that Clara Foods succeeds and is making not plant-based, but cell-cultured eggs for various industrial applications, New Harvest will have an endowment to fund more early-stage research. This is a very early-stage life cycle assessment that looks at cell-cultured milk's environmental impact versus, traditional milk's environmental impact. And while it's very speculative based on processes that haven't totally been scaled up yet, I think it's important to note, and it was also very encouraging to see that these cellular agriculture products can actually achieve a lot of the goals that we set out to solve. So for example, cell-cultured milk would produce 84% less greenhouse gas emissions, require 91% less land, require 98% less water consumption, and 65% less energy. And while I understand that these are all very speculative numbers based on a lot of estimations, I think even if cell ag milk is only half of what these numbers predict, I think it's still a very much important move in the right direction when it comes to deriving more food products from the planet that we have. So those are the products that are made by cells, but I think the perhaps more interesting work and definitely more cutting edge are products that are made of cells. And so this is where we focus on cell-cultured meat. The idea being that if a lot of the meat market is driven by boneless, skinless chicken breast that is trimmed of fat, why not grow that same muscle tissue from the muscle cell up rather than from the very complex chicken down? And I don't know how many of you have heard of cultured meat. Actually, maybe a show of hands. How many of you have seen cultured meat in the media? Okay, lots. So you probably have seen some of these images. This is a $300,000 hamburger that was created in August, or not created, but tasted in August 2014 in the Netherlands. This was an $18,000 per pound meatball that was tasted last year, and $9,000 per pound chicken finger that came out just a couple of months ago. And I like showing these images because they're usually the images that people have seen in the media, so they're a little bit familiar. But I also like putting those price tags on there to show a couple things. One being, a lot of you are scientists, and you'll realize how hard it is to scale down something that costs this much to the price of hamburger as it is today, that it's not really just about, oh, we'll just build a bigger factory and the price will come down. There's a lot of scientific innovations that come into play when it comes to actually doing that. But also to point out on a more positive note that the price of cultured meat has indeed come down a little bit over the past couple years. So when people see those images, they also get this sense like cultured meat is right around the corner, and oh my gosh, if these people are tasting this awesome dish of a cell-cultured chicken finger that I can too any moment now. But you actually can't. And I like showing this image because it's kind of brings it all back to reality. This image was put together by a journalist in 2014, and they mapped out all the predictions that people had made in the media about when cultured meat would hit dinner plates. And as you can see, a lot of those predictions have already expired. I think all the ones that have, I guess if you go to 2017 and go up, a lot of those predictions have expired, and a lot of the newer predictions have gone longer and longer and longer. So I think it's kind of one of those things where the more you know, the more you realize you don't know. And when people ask me, when is cultured meat going to be on dinner plates, which of course is a question that almost everyone asks me, I rarely answer, which is kind of disappointing. But what my answer is that usually when it comes to scientific discoveries, when people say that something is 10 years away, it means they have absolutely no idea when it's going to come back. And they hope that in 10 years you won't come back to them and be like, hey, 10 years ago you said this thing was going to happen. So I say 10 years knowing all of that. The reason why we don't know is because the more we delve into figuring out this problem, the more we realize there's a lot of issues associated with it. And I'll illustrate that all very soon. But this is kind of the big image that I like to show. This is the behind-the-scenes footage from that $300,000 hamburger that rarely gets shown. If any of you in the audience work with tissue culture, you see this and realize just how expensive this is. So when we look at that $300,000 price tag for that cell-cultured hamburger and then see this image, we realize why. What was happening there is we were doing a laboratory experiment growing a very small piece of muscle tissue, which was relatively routine in a tissue culture lab, but doing it thousands and thousands and thousands of times. So there's a lot of media here that comes from animal products. There's a lot of plastic supplies. That cell-cultured hamburger was actually way less sustainable than a regular hamburger. But what it did point out was that it was physically possible to do it. But I just want to emphasize how much work and how much research and discovery work needs to be done to go from repeating a laboratory experiment many, many thousands of times to actually producing cultured meat that will solve many of the animal agriculture issues that I pointed out earlier. So this is a very, very simplistic and basic schematic for how we would be producing cultured meat at scale. You would need 4 main elements. One are those cell cultures. So these are muscle cells from animals, and maybe some fat cells, maybe some connective tissue for chew, maybe some blood for flavor, who knows. But it could be any kind of cell culture from any kind of animal. And then you would need a scaffold on which to grow those cells. So there's a lot of options when it comes to the scaffold as well. Some people think it should be a spongy material that you actually consume with the cells. Some people think it should be a material that is consumed by the cells as the cells grow into it. Some people think it should be a scaffold that is very easy to scrape clean. So maybe huge sheets for cell cultures to grow on so you can remove the muscle cells from it and harvest it that way. There's tons of options in that area. And the third thing that you need is a medium, which is the food that you feed the cells. This is where all the nutrients come from, the amino acids, the fats, et cetera, that these cells need to grow and divide. And then all of that growth will take place in a bioreactor, which pretty much mimics a body, which creates all of the has all the appropriate inputs and outputs and temperature control that is required to do large-scale cell culture. And I'm sure many of you in the audience are very familiar with these terms. So this is some of the work that New Harvest is doing. My goal with cellular agriculture is to keep the research as open source as possible. And the reason why I'm interested in that is because I think food science, at some point, we went from it being the most open source technology ever to something that is not really that much at all. And when I want to avoid some of the issues that come with GMOs, which I don't think are science-oriented, which are rather legal in issue, I'd like to avoid some of that stuff with cellular agriculture. So one of our projects that we're funding at North Carolina State University is deriving the first poultry cells that would be used for creating chicken and turkey in cell culture. Amazingly, there is very little knowledge on agricultural animal cell lines as opposed to the ones that we use in medicine, which for some reason are Chinese hamster ovaries and canine kidney cells. So in deriving these very basic cell lines, it's work that very few people have ever done, and it's work that I think is completely transformative, because if we make these turkey cell lines completely open to anyone who wants them. We've lowered the barrier to entry significantly for any person or company that wants to innovate further when it comes to producing cultured meat. Marie here is the New Harvest Research Fellow that we're supporting, and her supervisor, Dr. Paul, is, when we met him, it was just so obvious that we wanted to support him. He had been keeping a culture of turkey cells in a -80 since 1993, and he said, I've been wanting to do this work since the early 90s, but the USDA wouldn't fund me, none of the grantors would fund me, my university wouldn't support me, and I'm so thrilled to be able to have this chance to do this like really transformative work. So there are actually many, many scientists out there who have been thinking about producing foods in cell culture for a very long time. Oh, this is a micro nugget that Marie produced. She actually tasted it, which is something we didn't tell her to do, and she said that it tasted like a very potent KFC. I don't know what that means, but we have a theory that maybe a lot of that flavor comes from the chicken serum that she needs to grow the cells in. So that's not so good for our mission. The second thing is this is some research that we're doing on Scaffold. So on the far side, we are growing muscle cells on beads. We realized that wasn't the greatest experiment because a lot of the beads that you would grow cells on these days are non-edible. But there are options for how to make edible beads too. And then on the side here is actually celery scaffold that we created, where we took celery and washed all the cells out with the intention of seeding muscle cells onto it. And what I'm really excited about with these plant scaffold projects that we're supporting is that it kind of extends our imagination in terms of what meat can be. So normally when I talk about cultured meat, we're just thinking hamburgers, hot dogs, steaks, all the status quo meat products. But when you think about, meat cells grown on a celery stick or meat cells grown into a mushroom, we can really get excited about the culinary opportunities that exist when you introduce this kind of new level of biotech to food. And I like to draw this parallel. Back when we very, very first invented biotech with fermentation, we could have never looked at milk and wanted it to be solid with holes in it, kind of stinky, melty. We could have never imagined cheese. And so what are the cheeses of the future that we can have as we introduce this new type of cell culture into our food system? So the third element is medium, and this is something we haven't touched on too much yet because we need to derive the cell cultures before we can design the medium to go with the cell cultures. But I like to point out that today the status quo for growing tissue culture in the lab is using fetal bovine serum or fetal horse serum, and it is unsustainable as it sounds. It is derived from unborn fetuses, and it's by stabbing a needle into a fetus's heart and kind of... So anyway, it's terrible. It's very unsustainable. It's extremely expensive. And I think that if we can't figure out a way to create a plant-derived, sustainable serum replacement, that actually cellular agriculture doesn't work. And we've done enough research to realize, okay, this is not the way we need to go. There's no evidence to suggest that it will go that way. I think there's a lot of work that needs to be done in terms of figuring this out. And I also think that if we figure out an animal-free serum replacement, that has an enormous number of applications in medicine as well. So it's a cross-relevant project. But it's something that we need to focus more on in the coming years. And then the last work is in bioreactors. The bioreactors that we've been working with so far are very, very tiny, so they're not as exciting to look at. But I like showing this picture of a brewery instead to stimulate your imagination about what the future might look like growing cell-cultured foods in mass production. This is very different than visiting a factory farm, for example. You can tour a brewery, you can taste things, and we perceive the people that work with these huge stainless steel vats of living organisms transforming foods as artisans and craftspeople and not as mad scientists. So we're actually very familiar with cellular agriculture already. So the way that we push our research forward is through a fellowship program, the New Harvest Fellowship Program, and these are some of the first New Harvest Fellows. And the way that the program works is each fellow applies with their own individual project, and we usually go back and forth with them, co-designing their project even further to make it more relevant to the timing of where cultured meat research exists today, and also more relevant in terms of how it collaborates and interacts with the other projects that we're funding. So there's some novel things that we do. We have a weekly Slack meeting where all of the fellows upload what they're doing, and we can see where everyone's falling into traps and things like that. And we have a research director who works with them as kind of like a remote laboratory manager, kind of pulling together all these distributed laboratories as if they were working together. Because as you can imagine, the person working on turkey cells is not working in a lab where other people are working on turkey cells. So there's a lot of unique challenges that each of these research fellows have that aren't the same as what their physical collaborators have. And we also have twice yearly retreats, and we have very interesting visiting scholar opportunities where we send our researchers to different labs to share things like supplies and cell cultures, but also techniques and expertise. The goal of the fellowship program is, there are three. The long-term goal is to create a new industry that solves a lot of the problems that I mentioned earlier. I really do believe that moving towards cell cultures for producing food is going to solve many different problems, but there is a long, road ahead to get there. The medium-term goal is to ask and answer fundamental scientific questions and put new science out there. A lot of our researchers are already at this point, and a lot of them will be publishing in the next year or so. And not only are we trying to do that with open source publishing and kind of novel ways of getting that research out there, but we're also trying to do novel things when it comes to sharing supplies with one another. So we're working with deriving an open MTA that allows us to share our cell cultures very easily and freely, and also making other things open, just like our imagery and our microscopy, just to get people and the public involved in this science at a very early stage. And the short-term goal is to train talent and foster expertise. There are some cellular agriculture companies out there right now, but it's very hard to hire because there are so few people who are experts in this specific area. So the fellows that we bring on, I hope, will be pioneers either in academic labs or industry labs in the future. So the goal is, if we look at the pattern of how we've been producing foods, especially animal products, over the last several millions of years, we've always been moving towards more controlled environments. And I think that it's really not so unusual to think that the future, past industrialization of whole organisms, is the cultivation of cells. So I'm just going to loop back to the entrepreneur thing to get our question and answer period more focused on that. But I think there are a few things that make me a very unconventional entrepreneur. The first one, which I didn't put here, is I actually don't really love being called an entrepreneur. And also that my work is done completely as a 501c3 charity. A lot of people along the way have said, why don't you make New Harvest a company? Why don't you join this accelerator or become an incubator and all this kind of things? And no matter how much I look at the science and where the science lies, I really believe that a nonprofit organization is the best vehicle to get this whole field started. The future, who knows? But I think there's a baseline of foundational research that needs to be done before we can go to those stages. The other thing that I think is different is we're trying to create an entire field. We're not just trying to create one entity. So we're trying to populate that field with as many people as possible. We're trying to train the talent. We're trying to bud off all these new groups because there's so much more resilience in building an environment around you than just building yourself. And the last thing that I think is different is that we're playing the long game. So I think a lot of entrepreneurs are just thinking about how to do things as fast as possible. I'm more interested in how to stick around as long as possible. Not because I want to be a charity that sticks around. Actually, I believe that charities should try to make themselves obsolete. But when I say we're playing the long game, I mean that I can understand and see why cultured meat, for example, is going to be many years out. There's just so much research that needs to be done. And we won't get there by rushing through it. We'll get there by meticulously looking at all the different research questions that need to be answered and being very diligent about that. And I think that there's a culture these days of doing things as fast as possible that I'm not sure is so great for sustainability. So with that, I will conclude my presentation, and hopefully we have time for questions. Yeah, sure. Great.